I can identify sets of given minimal conditions to prove two triangles congruent. So if all the corresponding parts of two triangles are congruent, then you know the triangles have to be congruent. But what if we didn't have to look at all six parts, all three angles and all three sides, just to know that the two triangles are congruent? What happens if instead there was a minimum number instead of 6? And it turns out that 3 is that minimum number. Sometimes if you just have 3 parts in common, then you can actually only make one kind of triangle, so the two triangles that have those parts have to be congruent. We're going to worry about exploring those later. For right now, we just have to practice identifying the set of minimal conditions we have in front of us. So we want to say, how do we name them? Everything will make sense, particularly in the next lesson when it all comes together. Let's just take a look at this and try and name these parts that were given as congruent. Here's the key. You want to put a dot, or we can think of it like a pothole that you don't want to drive over. Put a dot on each segment and angle without a tick or arc. Okay, let's take a look. There's no marking on this angle, there's no marking on this segment, there's no marking on that angle. You only have to do this for one triangle. So take a look. You are never allowed to go over 2 potholes in a row. You can go over as many as you like, you just can't go over them in a row. So you can't go over these 2, you can't go over these 2, you gotta stay away from this. So if you think of yourself outside, maybe like in your little car, and you're gonna drive around, you can start over here, you can start over here, I don't really care, but take a look. This is a side, this is an angle, and this is a side. So, what do you actually have for your minimal conditions? In this case, your group name is side, angle, side. You were given a side, a pair of sides congruent, a pair of angles congruent, and a pair of sides congruent. Notice the angle is included between the two sides. So the word included here means between. And E is between segment DE and also segment FE. So included means between, and if you put down dots on everything, just on one triangle, you cannot go over 2 in a row. So now we just want to spend a little time matching everything up. I like to go ahead and say, okay, I'm going to go with 2 ticks, 1 arc, 1 tick, and I'm just going to state everything, remembering order matters. Now, these ticks represent a side, this arc represents an angle, this tick represents a side. Again, that's the group name, side, angle, side we've been given for congruent parts. And if I name them starting in triangle 1, this is my triangle 1, and this is my triangle 2, I have to stay in that order every time I make a comparison. So here I go. I'm just going to say for this side, the 2 ticks, this is segment AB, and it corresponds to segment DE, and they're congruent. Order matters, A to B, D to E. How do you know to say to D to E? Look how A is at the end of the 2 ticks. D is at the end of the 2 ticks, so you know they correspond. Next up, the single arcs, angle B to angle E. They correspond and are congruent. Finally, segment BC, segment EF. You cannot say segment FE. Those are very different. They have to correspond. B corresponds to E, so if you start with B, you have to start with E. Now, this next one is particularly challenging. Again, put your dots down on anything that doesn't have a marking. There's no marking on that angle, or this side, or that side. You cannot go over 2 in a row. You can go over 1, and then maybe hit another one after something was marked up in between, but you can't go over 2 in a row. So what kind of group do we have? Well, that's an angle, that's an angle, and that's a side. So if you start again and drive around from either direction, just don't start in the middle. You have an angle, angle, side, or a side, angle, angle. You can actually say it's either one. I'm going to start with a single arc, a double arc, and a single tick. That's the order I'm going to go in. I'm going to say angle B is congruent to angle E, and that is an angle. Angle C is congruent to angle F, and that's an angle. And segment AC is congruent to segment DF, and that's a side. Watch the order. Last one. Put down your markings, your dots. You can hit pause and try this one on your own. There's no mark here, there's no mark here, and there's no mark there. Stay away from the 2 in a row. What do we have? Well, start on the edge of one of your group, one end of these boxes. Okay, let me see. If I go for a little drive, I have a side, and an angle. So you can say this is side, side, angle, or if you prefer, angle, side, side. Yes, that's a bad word. So I'm going to go 2 ticks, 1 tick, and a single arc. I'm going to say segment AB, A to B, D to E. That's a side. This will be a side, and that'll be an angle. This one here is segment BC. This is segment BC. Oop, forgive me, EF, BC, E to F, and then finally angle C to angle F. I can use single letters for the angles here because they're not sharing this vertex with another angle. You can use 3 letters if you feel better. Now, if this gets rotated or reflected, it's harder to find things. So notice for a second how E was between the 2 ticks and the 1 tick. B is between the 2 ticks and the 1 tick. That's how you know what corresponds to what. Pay attention to those things. What happens if you don't have these markings to start? Then what do? Well, you have to add them. So this same game is going to happen, but I'm going to take away the markings. What kind of markings am I going to put? Well, let's talk about how to annotate. This is non-negotiable. You need to put down both markings and words. You do that, you'll learn the vocabulary, and you'll be just fine. For example, if we come down here, we have definition of a bisector. So it says here that segment BV is bisecting angle CBA. So this angle right here just got chopped in half. Why was I able to put those markings? Because of the definition of a bisector. By the very definition of a bisector, it cuts the angle to 2 congruent parts. The markings go here. Angle ABV is congruent to angle CBV. Watch your order. And the reason you were able to put those markings, the definition of a bisector, goes here. These were given to you, this information up here. The word bisector was the reason you could put those marks. We're going to do a lot of this statement and then reason. You can't make a marking, which is going to be the statement, without a reason for why you were able to make it. It's going to go right next to it. I think this because this. Let's look at this next one. Definition of a midpoint. If K is the midpoint of segment CB, it means it's the halfway point, meaning the segments on either side are the congruent. Why was I able to make this marking? Because of the definition of a midpoint. By definition, the segments on either side of the midpoint are going to be congruent. So my statement, segment CK is congruent to, be careful of the order, segment BK. What's the reason why? Definition of a midpoint. You will be making these marks and these annotations a ton of times. Now let's go down and look at the last 2 for today. And the last 2 you haven't seen before. Well, this one you have. You know vertical angles, for example. If you had 2 lines that cross each other, these would be the vertical angles, or these here. And they're congruent. These vertical angles have opposite rays. The opposite of this ray is this, the opposite of this ray is this. So what are the vertical angles we have right here? Well, this is the pair we're talking about. And the reason I was able to make that marking, again, vertical angles. Have to justify any mark you make with words. So the statement, angle YUW is congruent to angle XUV. Watch your order. The reason, because vertical angles are congruent. Now the last one over here, reflexive. I like to think of this one like the reflection property. If you look at yourself in the mirror, you see your reflection. You are congruent to yourself. And that's what's happening here. If you take a look at this, the marking I'm going to put down is on segment DG. Let me resketch so I show you what I mean. If I take these two triangles apart, you can see how this segment here is in both triangles. And they correspond and they're congruent to each other because they're the same segment. So whenever anything is congruent to itself, like in this case, I'm only going to have this single mark on it, we call it the reflexive property. Not the reflection property, although that's pretty close. It's a good way to remember it. So the reflexive property just means anything can be congruent to itself. This includes angles. This example is just for a segment. So my statement would be segment DG is congruent to segment DG itself by the reflexive property. So now if we apply these down here, unlike before, I didn't give you all the markings. You only have 2 markings in this triangle compared to 2 in this, but we need 3 for our set of minimal conditions. What can we add? I have to use 2 ticks because I've already used 1 and I can't say these segments are congruent, but I know segment EY is congruent to itself. It's in both triangles. What's the reason why? The reflexive property. You put a mark, you put the words for the annotation as to why. Now let's go ahead, we've got our 3 marks. Let's put down our dots or our potholes on the angles and sides that don't have marks. These don't. Neither does this. Let's see, I just can't go over these 2. So what's the name of the group I have? Well, I have a side, and an angle. Or an angle, a side, and a side. So I'm going to go ahead and say this is side, side, angle. And, or I could say angle, side, side. And I'm going to go ahead and go 1 tick, 2 tick, and my right angle symbol. That happens to be an angle. These are both sides. Just make sure your parts correspond now. Segment RE is congruent to segment VE. Segment EY is congruent to segment, you've got it, EY itself. And angle EYR is congruent to angle EYV. And we needed to use 3 letters because I can't just say angle Y. I don't know which one we're talking about because the vertex is shared by more than one angle. So remember your potholes on anything that doesn't have a marking, and then use your new vocabulary to annotate followed by the reason why every time if you don't have your 3 marks for your minimal conditions. Good luck.